Hello friends, welcome back to Maths So Plain. So here we are with a new trick. In mathematics, we are taught a series of formulas. Consider for calculating area, we have got Heron's formula. The basic half into base into height root 3 by 4 a square for equilateral triangles, etc. etc. For integration, we have methods like by parts, Queen's formula, integrating factors, and this list is never ending. Sometimes these options may become confusing, as in what to use in the given situation. But still, more options are worth it. But for something as basic as multiplication, were we ever taught different methods? And even we didn't mind because it's just multiplication, right? But what about multiplying numbers like 987 into 992? What if we had a simpler way out? So let's dive in and see for yourself, is learning this technique worth the extra formula? So let's do multiplication using the base rule. The first question which might arise is, what exactly are bases? What do they have to do with multiplication and how to calculate them? Bases are basically powers of 10, like 10, 100, 1000, 10,000 and so on. Now they act as base for the numbers nearest to them. For 14 or 9, the closest base possible is 10. Similarly for 97 or 106, 100 is the closest base possible. So we assign 10 and 100 as the bases respectively. Now for calculations, we are going to use base complements of respective numbers. So the next question is, what are they and how to calculate them? Base complements are simply defined as a number subtracted by respective bases. For 8, our base will be 8 minus 10, that is minus 2. Similarly, for 106, it will be 106 minus 100, that is positive 6. So let's begin with a fundamental example. We all have 7 into 9 by hearted. The value is 63. Multiplication tables, right? Let's try it with the base complement method. Now write 9 vertically below 7 and to the right of each number write its base complement. For 7 it is 7 minus 10, that is minus 3, and similarly minus 1 for 9. So we will multiply minus 3 to minus 1 to get 3. This will act as our unit digit. Remember, the multiplication of both the base complements should have number of digits equal to the number of zeros in the base. Otherwise, we have to take carry. Don't worry, we have a separate example for that. Now, there are two methods to find the tens digit of multiplication. First is to add both the numbers and subtract by the base, which here becomes 7 plus 9 minus 10, that is 6. Second is to follow cross addition, either 9 plus minus 3 or 7 plus minus 1. Both will always be same, in this case 6. So we write 6 before the slash and 3 after the slash. One very important thing to be kept in mind is that the digits in base complement are same as the number of zeros in respective base. So placing the cross-added digit to the left of slash and that acquired from base complement multiplication to the right, we get a final answer, that is 63. Now examples like this will tell you how much time you can save using this trick. So let's try 97 into 98. Here base complement for 97 is minus 0.3 and for 98 is minus 0.2. Now on multiplication we get 0.6. Note that it is 0.6 and not just 6. On cross addition we get 95. Thus the final answer is 9506. Look how fast and simple it was. I hope you're beginning to appreciate the presence of an extra option for multiplication. We took two examples, both of numbers below the base. Now let us try 104 into 106, that is, both the numbers above the base. Base complement for 104 is 04 and that for 106 is 06. On multiplication of base complements, that is 04 into 06, we get 24. On cross addition, we get 104 plus 06 or 106 plus 04, that is 110. So we get the final answer as 11024. So I hope we are all on the same page now. As we get comfortable with the trick, let's try a new variant. One number above and one below the base. So 98 into 106. So the base complement for 98 is minus 02 and for 106 is 06. On multiplication of minus 02 and 06, we get minus 12. Confused, huh? Let's continue the method anyway. On cross addition, we get 106 minus 02 or 98 plus 06, that is 104. Now, the main problem is what to do of this minus 12. So we can write it as minus 100 plus 88, right? So the problem is solved. The last two digits will be 88 and the hundreds place or minus 1 is subtracted from 104. Thus 104 minus 1 yields 103. So the final answer is 10388. You might be wondering what to do if the multiplication of base complements has digits more than the number of zeros in base. So here is an example for you. 108 into 116. So the base complement for 108 is 08 and 116 is 16. So multiplication of base complements, that is 08 and 16, yields 128, which is more than the number of zeros in base. I hope you are clear by now how to tackle this problem. On cross addition, we get 124. Now 128 can be written as sum of 100 and 28. Thus we have to write 28 to the right of slash and add 1 to 124. That is 124 plus 1 equal to 125. So the final answer is 12528. Now that we are acquainted with the trick, let's try the question we talked about in the start of the video. 987 into 992. Base complement for 987 is minus 013 and that for 992 is minus 008. Now multiplying the base complement minus 013 and minus 008, we get 104. On cross addition, we get 979. So the final answer is 979104. So thank you for watching the video. I hope you enjoyed it and will use it. If you liked the video, please subscribe and feel free to ask doubts in comments. So goodbye till the next time.